This is chapter 15, where we'll use a much better technique for configuring your AOP, the AspectJ Pointcut syntax. I'll need to tell you what a Pointcut is first, and then we'll see that using this new technique, our advice class can be a plain Java class, rather than needing to implement a special interface. That's not a great big deal, but it is a bit more elegant. Then, for the first time on the course, we'll use something called a namespace in the XML. This is an additional set of powerful tags. The AOP namespace lets you configure the proxies in a really straightforward way. This is quite a long chapter because I've included yet another alternative configuration. You can use annotations instead of XML. I don't like this, and I'll tell you why when we get there, but in case you like it or need to use it on your project, we'll spend the last 10 minutes of the chapter on that. The AOP that we studied in the previous chapter is the most basic form of AOP that Spring supports. But so far, we've only applied advice to a single class. Now, usually, we'll want to apply advice to more than one class. In our performance timing advice, for example, we would want to apply the advice to all of our service classes. And this means, using the approach that we've used so far, we would have to repeat this block of XML here for every one of our services. Also not good is that we would have to remember to do that as well. Imagine that if we write a new service class but then we forget to set up one of these proxies, then that service class will now not get the advice applied. Now that's maybe not a big problem if it's just this timing advice, but if the aspect was something more serious such as security, then we would have a real problem. We'd have an unsecure system. Now, in version 1 of Spring, you could fix this problem using something called an auto proxy. It worked okay, but it was a little bit complicated and it did still result in quite a lot of XML. I did cover this in the first edition of the course, but these days, most projects, probably all projects, avoid using the method of auto proxies. So I'm going to call that the old-fashioned way of doing things. In this chapter, we're going to replace the work we've done, and we're going to switch to the new features that were added back in Spring 2. And these new features really do make AOP much simpler and more powerful. And the biggest of these new features is something called a Pointcut syntax. Now, this allows you to declare to Spring that we want the advice applying to more than one service class really easily. And we can go even further. We can make the advice only apply to some of the methods in those classes. It gets really powerful. So we're studying this new Pointcut syntax. Well, Pointcut is an interesting jargon term. What does it mean? Well, a Pointcut is a set of rules determining to which methods and in which classes a piece of advice should be applied. So, for example, we might have a piece of advice that we want to apply to all of the methods beginning with the word get in all of our service classes. So in other words, this piece of advice I want to apply to all querying methods in my service classes. As I've mentioned, using Spring XML to do this would be really difficult, but this new Pointcut syntax makes it really quite easy. In Spring 2, the people behind Spring decided that they would borrow a syntax invented by AspectJ. Now, I briefly mentioned AspectJ in some of the previous chapters. Here's their website. The URL you can see here. It happens to be hosted by the Eclipse project, but is in fact independent of the development environment. So this is another open source project which is completely independent of Spring. This is a dedicated aspect-oriented programming framework, and it's an incredibly powerful framework. It goes far further than the AOP that we can do in Spring, but it does have a much steeper learning curve. One thing that AspectJ have always had is a point-cut syntax. And this syntax will allow you to express your requirements in the form of what essentially looks like a wildcard. Now, Spring have borrowed this syntax and absorbed it into Spring AOP. Let's have a look at a few examples of what this point-cut syntax looks like. Let's assume that we've written some kind of advice. It might be performance timing like we did previously, or it could be something like security or transactions. And let's assume for some reason that we want to set up the advice so that it's going to apply to all methods in all of our service classes that begin with the word get. Now, a bit ambiguous there. I mean, the methods need to begin with the word get. Now, what we can do using this AspectJ syntax is we can specify our requirements in a single string. And it looks something like this. Now, be a little bit careful. This isn't complete yet. It's not correct. It wouldn't actually compile. But I'm going to build it up and add more elements as we go through further examples. And it will give me a chance to explain the concepts. The key thing about the point cut is it's really nothing more than a wildcard. I'm saying here I want to look for all classes with the word service in them. So I'm beginning with an asterisk and I'm ending my class name with an asterisk. And then I'm saying with the dot that the advice must only apply to methods beginning with the word get. And then, of course, with the asterisk here, we can have any characters in the rest of the method name. So that's the core of an AspectJ point cut. And if we were to use this syntax in AspectJ, AspectJ would look for all of the matching classes, and then it will focus on the matching methods in those classes, and it will weave the advice into those methods. Well, this isn't an AspectJ course, it is a Spring course, and from Spring 2 onwards, they've absorbed the same syntax. They've borrowed this point cut syntax from AspectJ, included it into Spring. Please don't get confused. We are not using AspectJ in this chapter. We're still using Spring AOP, and that means we're still using the same dynamic proxies that we've been working with throughout. It's just this syntax for declaring the advice in the XML will be a lot cleaner than before. Now, this syntax can get really quite sophisticated. I'm going to build this example up and show you some alternatives. For example, we could change the requirements and we could say that, well, actually, we now want the advice to only apply to methods in the service classes, but they must begin with the word get. That's the same as we had before. But we only want the advice to apply to methods that take a string as the first parameter, and then for the second parameter, well, we don't care what that type of parameter is. It could be an int, a boolean, a float, a long, and so on. But it must have a second parameter. Now, this is really quite useful because you might have some advice that's very specific advice and only needs to target a certain class of methods. Well, by being specific about the types of parameters that the target methods are accepting, you can really focus on the method that you're looking for. Well, I would say it's quite unusual to be so specific about the types of the parameters that you want. So I'll change the example again, and we can instead use this dot dot notation. And the dot dot notation means we really don't care about what types of parameters are accepted by the target methods. So this really does mean all methods beginning with the word get, and it could have no parameters or one parameter or 115 parameters. Now that was my intention with the very first example I showed you, but I need to point out that you do always need the round brackets, and you've got to say something about the parameters. So this dot dot means we don't care. Now it's not just the input parameters that we need to consider. We can also discriminate our advice based on the return types of the target methods. Let's be more specific and say that, well, this advice only needs to be applied to methods in service classes beginning with the word get, but they must return lists. So I've made the change here at the front of the point cut where specifying the return type of the matching method. So in this case, if a target method in a service class is a void method or returns an integer, then the advice would not be applied. We're only going to apply the advice to methods that return lists. Now, often, probably most of the time, you don't care what the return type of the target method is. In which case, once again, you would use a wildcard for the return type. So I'm going to change the example again. Now I'm saying I don't care what the return type is. Now you must always have a reference to the return type in the Pointcut syntax. That's why my earlier examples wouldn't work and wouldn't compile. You've got to have something here, either an asterisk or a specific type name. Well, I have to admit that the expressions I've showed you over the last few minutes haven't actually been full AspectJ Pointcut expressions. They wouldn't have compiled because we always have to specify the phrase execution at the front, followed by round brackets. That's because we're applying this advice to all of these method executions. Now that's a bit strange because in Spring AOP, really all of the advice is applied to method executions. It's just that in AspectJ, in the true full AspectJ framework, you can do lots of other types of AOP, such as, for example, you can apply advice to whenever you read an attribute's value and not just when you call methods. So in the full AspectJ syntax, there are other phrases that you can put in place of execution. But to be honest, in Spring AOP, not much of that is supported. You're almost always going to see the phrase execution here at the front of the expression. There are some alternatives, and I'll show you those in the Spring Reference Manual later in this chapter. I hope that gives you the general idea of how to write these Pointcut expressions. We're going to be practicing writing a few shortly, but before we can do that, we need to see how to actually apply these Pointcut expressions in the Spring XML. So just to remind ourselves of where we've left things, here is the application.xml file for our books store. And remember in the previous chapters that we have taken our book service and we've renamed it book service target. And we've created a new class, a new bean rather, called book service, which is one of these proxies. And it's this proxy which adds the advice. And we created a separate bean for the actual advice. Well, I've already indicated that this is a kind of a simplistic way of working, and I think it's fairly understandable, but it does get very unwieldy in the XML. So if you're following along with me, we're going to undo the proxy. I'm going to delete the entire proxy bean, I'm going to leave the advice in place because we're still going to need that. And I'm going to go up to the point where we created the book service target, and I'm going to revert it back to being called book service. Now, I think I referred to book service target here, so I'll need to make sure that that has been changed back. Just to make sure I haven't broken anything, I'm going to run the client again. And I just want to check that the system is running without any advice applied. And yes, it looks like everything is running okay. Now, before I show you this improved support for XML, I also want to mention another big improvement that was introduced in Spring 2. Let's find our advice class. This is the performance timing advice that we've been working with through the course. And recall that we were absolutely forced to implement this interface called method interceptor. That contains a single method called invoke, which contains the payload of our advice. Well, in Spring 2, they dropped that requirement, and the advice that we write can be stored in a plain Java class. Now, this has two, I think, really big advantages. Well, the first easy advantage is we don't have to remember to implement the interface, and we don't have to remember the interface name. But for me, the big improvement is that means that the method that we write, we can call anything we want. Whereas before it had the rather unpleasant name of invoke, now we can give it a meaningful name. I've called my performance timing method here time method, which just by looking at it, I can tell what this method is doing. Whereas the old version, it wasn't immediately obvious. Now, the other advantage is that using this old-fashioned way of doing things, you were only allowed one piece of advice in that class. So if we were working on a complex project and we had maybe, I'm making this up, but if we had different ways of doing the timing, and we might have 5 or 6 different versions of timing, we would have to create a separate class for each of those pieces of advice. In the new way of doing things, because this is just a plain Java class and we won't have this interface here, we can have those 17 methods inside here, all with different meaningful names. I think that's really valuable, so we can group related advice methods together into a single class. Now, there is just one requirement on the method that we write here. So I've written a method here called time method. If we are writing around advice and therefore we need to proceed somewhere in that code, we are forced to have one single parameter in the method, and that parameter is called proceeding join point. Now, that's a little bit jargony, and for that I apologize, it's a bit awkward. This is really a replacement for this method invocation parameter that we had before. Now, I do not know why they changed it for a completely different class, but they did, and we've got to work with it. So if you're following along with me, we need to make some changes to this class to make it a plain Java class. And the first thing we can do, and this feels good, is we can remove the method interceptor interface. And then we can change the method name. It can be anything we want now. You could call it invoke, of course, but I much prefer something meaningful here. And in fact, I'm going to change what was on the caption just to prove that it can be anything. I'm going to call this perform timing measurement. Remember, though, the awkward thing is that we are going to have to change the parameter here, and it's going to be this class called proceeding join point. Well, if you're like me, you won't want to type that in. So once you've typed the first part, a control and space or command space on a Mac, and that's the only matching class, and it's filled it in. And if you have a look here, you'll see that that class does come from the AspectJ framework. Now be careful when you're typing that. That is proceeding and not preceding. So make sure you're careful with the spelling there. Now I have a compile error here at the moment, purely because I've still got the override annotation. Now that was useful when we were implementing an interface, but we're not extending or implementing an interface or superclass here, so the override annotation must be removed. Now that's compiling there, but I do have a compile error here, and that's simply because with this preceding join point, the method names have changed. There is a method in there called proceed, and that's okay. But if we want to get details of the method that we've called, it's slightly different. They've changed it to get signature instead of get method. If you just make that change there, you can see that everything else compiles. So I know it seems a little bit awkward having to make these little changes. You do have to make these changes because I'm afraid the advice that we had before would not have worked using the AspectJ Pointcut syntax. So we need to look now at how to actually declare this Pointcut syntax in our XML. Well, this is a big change for the course. This is a big leap forward for us. Up until now, we've been using the bean tag and the property tag in our XML, and that's been pretty much it. Well, in Spring 2, they changed the XML quite dramatically, and they brought a whole raft of new tags into Spring. And these new tags are much more powerful than the old bean tag. They can do a lot more stuff. Now what I'm showing you here on this slide is, well, first of all, I'm declaring my advice bean exactly the same as I did before. But here in this block, I have a completely new block of Spring configuration. The AOP:config tag allows me to define the configuration of all of my aspects. Now, I must stress, this is quite an important point, that the end result of using these tags is exactly the same as we had in the previous chapters. Spring is going to go away and create some dynamic proxies for our services. It's just that we don't have to manually and laboriously declare those proxies anymore. The block of code you can see here that I'm highlighting is doing all of the work that we had in lots more lines of XML previously. Let's go through it all. First of all, I'm telling Spring that I have an aspect, and the ref is pointing to the advice class that I'm talking about. In my case, it's this bean called logging advice. I've always had that logging advice bean. And then inside that tag, I'm telling Spring that I want this to be around advice. So notice now that it's in the XML that we say whether it's before, after, or around advice. And that's one of the reasons why we didn't need that interface anymore in our code. And it's really simple, this tag. All I need to do is tell Spring what method I want it to weave. And here I would simply refer to the method that I have in the advice class. On the captions, it's time method. I think I gave it a different name in my code in Eclipse, but we'll look at that in a few moments. And then the second parameter here is the point cut. Now, you know what the point cut is by now. That's that big, heavy wildcard that tells Spring which classes we want to apply this advice to. And then we're done. Spring will automatically create all of the proxies that we need to match that particular point cut. Let's switch across to Eclipse and give this a try. So we've already got our advice bean created. This is the performance timing advice. I called the bean logging advice for some reason, but in fact, if you don't mind, while I'm here, I'll just give this a better name. Let's call this performance timing advice. That won't break anything because at the moment I'm not referring to it. Now I'm going to add in then the tag that you saw on the slide now, that's AOP:config. I want you to notice that I'm not getting any auto completion in here right now. Now there is a reason for that, and I'll tell you about that in a few moments. If you're following along with me, you will have to type this in longhand for now. So inside there, we're declaring that we have an AOP aspect, and this particular aspect is going to be using the performance timing advice. So I need ref equals performance timing advice. Now that's going to be an outer tag for what is really the important tag in all of this. This is going to be AOP: around. And of course I could specify before or after here if it was a different type of advice. And we've got two parameters here. The first parameter is a reference to the method that I want to call. Now the method in performance timing advice I've called perform timing measurement. And that's the reason, by the way, that you can have lots of different advice methods in this class, because we refer to the one we want here. And the second parameter in here is the point cut that we are applying. Now we haven't practiced using these point cuts yet, but I did show you them on the previous slides. So it's going to be something like, we need that execution first of all, and then some round brackets. And inside the round brackets, we use the wildcard to specify the class of methods that we want this advice to apply to. Well, I don't care what the return types of the methods are. Regardless of what they return, I want the advice to be applied. So I begin with the asterisk. Now I want the advice to apply to all of my service classes. Now I could kind of use a clunky wildcard along the lines that I did on the captions, which was something like asterisk service star. But in fact, there is a better way. Something I didn't tell you in the theory is that we also need the package name that we're interested in at the front of the class name. So I can be explicit and say that I want the advice to apply to all classes in the com.virtualpairprogrammers.avalon.services package. And then with a dot star, I mean all of the classes in that package. Now you can use a wildcard based on the class name, but you would actually need an asterisk for the package name if you didn't care what the package name is. So this asterisk here is referring to the classes that we're interested in, and that's going to be all of them in that package. But then we need another dot followed by the names of the methods that we're interested in. Well, I want to time all methods in those classes, so I'm going to have another asterisk here. Now, I admit, I agree that these point cuts do get quite complicated and difficult to read. It's just the nature of the way they are. They're very powerful and flexible, and therefore there are a lot of elements to the syntax. You'll get used to them over time. We're not finished yet, so this means all methods in the classes that we found, but I also need to put in round brackets and then declare what input parameters am I interested in. So if I said, for instance, string here, then this advice would only be applied to methods in the service classes that accept one single parameter of type string. Alternatively, I could put an asterisk in there. Now, be careful, that might not be quite what you think it is. That means that the methods must have one single parameter, but the parameter can be of any type. Now, that's not what we want. We don't care about the input parameters. There could be none, there could be 100, and they can be of any type. So we need that ... syntax. Now that was absolutely exhausting, and I'm not guaranteeing that I've got that correct. There could well be a typo in there, But really the only way to check these out is to try them and see. So that's the end of that tag, and that's the end of configuring that advice. So even if I had 100 service classes, this advice would now be applied to those 100 service classes with no further work. Well, you may notice that I've got an error here, and well, the error might not be particularly readable. It's saying the prefix AOP for the element AOP config is not bound. And I can tell you now that that was the reason that we weren't getting the autocomplete working either. There is one catch with these new AOP commands. These commands were, as you now know, added to Spring in version 2. And at the same time in version 2 of Spring, they brought in a new way of validating the XML file. Right here at the top, and it's been there since the start of the course, we've been using this tag called doctype. Now, I don't know if you know what this is. If you don't, it's from standard XML. It's called a document type definition. And it's basically pointing to a file, this file here, ending in .dtd. And that file defines what is valid in this document. So Spring have provided this file called springbeans2.0.dtd. It's actually stored in one of the jar files that you have in your lib directory. And it's telling the development environment really what is legal in this document. So the file is saying, for example, it's legal to have a bean tag, and it's legal to have a property tag inside a bean tag, but it is not legal to have a property tag outside of a bean tag. You can see as soon as I typed in that tag, I've got a squiggly red line, and that's because I'm violating the rules inside this file. So I'd better remove that. So that's fine, but I don't know if you know this, but a DTD is quite an old-fashioned way of doing things in XML. As XML got more sophisticated, the XML committee, essentially a committee, set up a second way of validating XML documents, and they called it an XML schema. Now, schema basically does the same job as a DTD, but it's a lot more flexible and a lot more useful. And the reason this is relevant to us is that in Spring 2, the Spring 2 people decided that for any extensions to the XML, any new features that they add to the XML, such as these new AOP tags, they were going to use a schema to validate those tags instead. So this DTD way of working was kind of deprecated and made less important. You can still use it, as we've been doing throughout the course, but for any new features in Spring, you have to stop using the DTD and move across to the schema. Now, I did want to use the DTD for the early part of the course, just so you've seen it, and you're going to find a lot of projects still using it. But now this DTD has served its purpose, and I'm afraid it's time to retire it. So we're going to need to delete the 2 lines at the top of your XML file. And we're going to bring into here a pointer to the schema instead. But there is a problem, and you'll know this if you've worked with XML before. Schema definitions are horrible, and you would certainly not want to type these in by hand. In fact, let's switch across to a caption to have a look at what they look like. So this tag, in fact it's 4 lines long, is what we need to add to replace the old DTD. And yes, I admit it's ugly. Now, the first thing I want to point out is that this is in fact an entire tag. And if you look carefully here, you'll see that it is the beans tag. So this is slightly different. The text you can see here is not going to go right at the top of the XML file like the DTD did. instead it's going to replace this line here. Or alternatively, we need to add the new stuff into the angle brackets there. And it is quite a common mistake that people make, that they copy and paste what you've just seen into this line here, and then I'm afraid you've got two beans tags, which is not correct. Now this is not an XML course, so I'm not going to bore you with what all of this means in detail. It's enough to know that you need this text if you want Spring to validate using a schema and therefore to use the new AOP tags. But I think as a developer you should have at least a vague grasp of what these lines mean. So let's go for a quick overview. This line here is saying that we are wanting to use a namespace called beans. Now, a namespace in XML is a collection of tags. Now, we're saying then that we want to use Spring's collection of tags from this namespace called beans. Now, this namespace contains all of the tags that we've been working with on the course so far. That's got tags such as beans and bean and property and all of those basic tags. Now, the next property that I've added here isn't actually required, but it is very useful in development because this will enable things like auto-completion and syntax error highlighting. This XSI : schema location is telling the parser, the XML parser, where to find the file that defines the namespace. There's two elements here. Here is the same string that appeared at the top, and the second string is the actual name of the file, the so-called XSD. And this file, a bit like the DTD, will be inside one of the Spring jar files. Now, this really isn't very nice, but I promise you I have not typed this in myself. You are definitely going to want to copy and paste this string. Well, where did I get that string from? Well, the reference manual. Here I am in chapter 33 of the reference manual. Now, of course, by the time you follow this course, the chapter number may have changed. But if you look in the contents page for something like XML schema-based configuration, then you should find the information you're looking for. And if we go a little further down, they're showing you here how to change from the DTD that we had before to this schema-based definition. And what you can see here is exactly what I've just shown you on the caption. And if you feel awkward about copying and pasting, notice here they even say this is boilerplate that you can copy and paste. So we'll do just that then. It's this text here that we're looking for. I've just taken there the beans tag. Back into my XML, I need to remove the existing beans tag and paste that into place. And now you can see that my tags such as bean and property are all fine. There's no big red squiggles underneath them. But well, we still have an error under AOP config. And that's because Spring have decided instead of putting everything into this beans namespace, they've decided to create separate namespaces for each of the major areas of Spring. So if we want to use a set of tags for a particular area, such as AOP, then we've got to add another namespace into this definition here at the top. Well, it's not pleasant, but once again, we can go into this chapter 33. And if you have a look in chapter 33, you should find somewhere, well, there's quite a lot of stuff in here. I'm just going to do a Control F and I'm going to search for AOP schema. And yeah, it's taking me back to the contents actually, but we're still in chapter 33. At the time of recording, it's 33.2.7. And that's going to show me the exact text I need to bring in the AOP namespace. Now I can do one of two things. I can either copy the entire tag there because it just so happens that they have left in the bean schema in this example. But more generally, as you go forward with your schemas, you need to learn how to unpick the pieces you need. We just want to add the AOP element, so I need to really copy two separate things. First of all, I need the namespace declaration, which is that string there, and that's going to go alongside my existing XML namespace definitions. And then the schema location is actually one big string. So I need to copy these two elements here. Essentially, I'm just looking for everything that contains the phrase AOP. And I'm just going to copy that and drop that into the same string. I know that's confusing. You would have expected separate strings for that, but it is one big long string. Now, nobody likes doing this, and if you're hating this, then don't worry, I am too. Now, if I save again and go back to the bottom, this is looking quite encouraging because you can see we don't have that red squiggle anymore under that tag, so it appears to be correct. So I'm sorry that that wasn't very pleasant, but it is a one-off job. We won't have to keep doing that. We've now got the AOP tags available and we can use them freely throughout this document. So that's all good as long as it works. Let's go back to our client and see if there's any difference. And I have a big ugly exception, and I kind of expected this. Whenever you write a point cut for the first time, you're never going to get it correct. They're just too awkward to write. And the thing I've noticed immediately is point cut is not well formed. It's giving me some kind of clues here, but I often find it's just better to stare at the point cut and see if you can spot the problem. And well, I don't know if you spotted it for yourself. I did say there would be a typo in here somewhere, and I've completely failed to spell execution correctly. Execution. That's very embarrassing, but I can't go back and correct it in the video now, so I'll just have to go with it. Usually there will be some kind of problem in here as well, but let's try that. And oh, well, it ran through okay this time. And I am getting output for register new book, get entire catalogue, and get book by ISBN. So it looked like my point cut did work. And what I really recommend you do, if you're following along with this, is to play around with the point cut and try different alternatives. If you're not following along in this bookstore example, then you're going to be doing pretty much the same job in the next practical session. And you'll definitely want to play around with this point cut. So, for example, as I suggested on the theory session, we could make this advice apply to only get methods. So it's this asterisk here, which is the method. So I could just say get star rather than all methods. And yep, it's now working for get entire catalogue and get book by ISBN, but not register book. And I could, well, the possibilities are endless really. I'll return that back to an asterisk, but this time I only want to apply the advice to methods that return lists. And oh, I have an exception again. And the reason for the exception, and this is something I didn't tell you in the theory, is that it's not sufficient just to say list. You have to say what package that class comes from. This is from the Java util package, so you need java.util.list. If I run again, hopefully this time, yeah, we're getting the advice applied to get entire catalogue because that returns a list, but it's not being applied now to the get book by ISBN method because that just returns a single book. So that's it then for our around advice. Now there are a few things to be aware of when you're writing either before or after advice. Now we don't have any before or after advice in our project at the moment, so I'm just going to very quickly add in a new method into our advice class, and I'm going to make this some before advice. I don't really know what to call it because I'm not going to do anything serious, so I'm just going to call this before advice testing. And a little like I did earlier on in the course, I'm just going to use this to log the fact that we have entered a method. So it will be a system.out.println now entering a method. Now in a few moments I'll show you how we can output the name of the method that we've entered. But for now, that should be enough. And notice that because we're not writing around advice, we don't need to proceed in here. The proceed is automatic at the end of the method. Therefore, I don't need this parameter called proceeding join point. So I can simply leave the method without any parameters. Now I'll need to configure that. So back into the XML, and I can add in another block of AOP. This time it's AOP colon before. And the method this time is, well, I've forgotten the name of it already. It's before advice testing. And the point cut, just to keep things simple, I'm going to make the point cut be the same as before. So I'll do a copy and paste. Well, it's not good to copy and paste, and I'll show you in a moment how we can improve that. But for now, I'm going to copy that point cut, and we're expecting this point cut to be applied only on the get entire catalog method. So let's see if that runs. And good. If you have a look carefully there, you can see that the advice was applied and it fired just before we went into get entire catalog. I just want to comment, by the way, did you notice just how fast it was to set up that advice and apply it? I would have taken a lot longer using the old-fashioned Spring AOP. But the point that I'm leading towards is, what if we do want to get details of the method that we've accessed? So I want to put the name of the method here. Well, if you want that, then you have to add in an additional parameter to the method. And it's very similar to proceeding join point, but this time it's just called join point. And I guess the reasoning behind this is proceeding join point is for around advice because you need to proceed, but the join point is the version for where you don't need to call proceed. So I'll just call that parameter JP. It will need importing, and notice it's from the same package as proceeding join points. Once I have this object called JP, of course I can call its methods, and if we have a look inside there, you're going to find basically the same methods as inside proceeding join points. The main one would be get signature, which will allow me to get the name of the method. I can get a few other things as well, such as the modifiers of the method, the declaring types, and so on. So let's give that a run. And great, you can now see the name of the method inside the advice. Now, while I'm here, let's go back into the XML. One rather annoying thing I did there was I copied and pasted this point cut. And it's certainly the case that often you want to reuse point cuts in your AOP. Much better than copying and pasting this string is we can define a common point cut that we can reuse across our entire system. And we do that just by going into the AOP config tag, and I can use the AOP point cut tag. And there are two parameters here. The expression is, of course, the point cut expression itself. So I'm going to cut out that entire expression and paste it into there. And the ID, I'll tidy this up a little bit. The ID just needs to be a name for this point cut. And what you should use here is something strong and recognizable and readable. So this point cut is describing all service methods that return lists. and don't be afraid to use quite verbose names here. And then the way that we reference this point cut is slightly different to what we had before. Instead of the point cut attribute, we use the pointcut -ref attribute. And then we simply paste the name of the point cut into the string. And so I can do exactly the same thing here. Pointcut ref, followed by our nice readable name. Just check that works. And yes, the advice is still being applied. So we've seen how this new AOP namespace dramatically cuts down the amount of XML that you need to write. Now, I know a lot of you won't like XML, but I think this is a really good, compact, readable and understandable AOP namespace. Very, very well designed. However, there is another approach to configuring AOP in Spring, and that's using annotations. Now, I have to be completely honest here, and I'm going to say that I don't personally like using annotations for AOP in Spring. Annotations are good for some other purposes that we'll see later in the course, but for AOP, I much prefer the XML. However, you might love the annotation approach, so of course we need to look at it. You're probably aware that XML is becoming unfashionable in Java these days, and there is a big move across to annotations. So the benefit of the annotations is that if you want, you can completely remove all of this XML. So I'll do that. And we need to replace that block of XML with one single tag. It's another tag from the AOP namespace. In fact, you can see it's popping up here on the autocomplete. The tag is called AspectJ auto proxy. It's just a single tag. You don't have to provide any further information. Now, this is, I think, the first of these kinds of tags we've seen on the course. This tag isn't really configuring anything. It's more of a command. It's telling Spring to go off and look for annotations in the code. So I'll reflect that in a comment. Tell Spring to search for AOP annotations. And the idea is, instead of writing any further XML, we're going to go into our advice class and we're going to use regular Java annotations to tell Spring how this advice should be applied. Now, of course, I don't know if you know about Java annotations. Annotations have been around for a long time now, so I guess by now you've probably come across annotations in some form. But just in case you haven't, an annotation is wherever you see the @ symbol followed by some kind of a marker. And in our case, the marker that we're using, the annotation that we're using, is the aspect annotation. Now, these aren't really Java classes, but they can be imported just like any other Java class. So I just did the Control-Shift-O there, and you can see that this aspect annotation has been imported from the AspectJ package. Now, you can think of an annotation as being like a comment, really. Just having this annotation in place isn't going to do anything. It's just a marker on the class. But what's going to happen when we have this AspectJ auto proxy command in our XML is Spring is now going to do a search at runtime. When we run the code, Spring will search for any class with the aspect annotation on it. And because we've put this annotation in place, Spring knows that we want this to be advice. So at runtime, Spring is going to find this class, and Spring is going to know that this class is an aspect. But we need to go a little further. For each of the methods, we need to add a further annotation to say whether this advice is before, after, or around. So our perform timing measurement method is around advice. So we add in the @around annotation. Again, that will need to be imported. Now, I have an error there, but I'll come back onto that in a minute, because I also need an annotation down here for my before advice. And of course, you've guessed it, that annotation is going to be at before. Do be a little careful here. There is a before class, I guess, in the JUnit framework, so that is ambiguous. You need to be sure to pick the AspectJ annotation. Now, the reason we have a compile error here is because in round brackets, we need to specify the point cut for this piece of advice. Now, the way that you configure a point cut, and I must admit, I find this really confusing. We declare a method in our class. Very strange this. The method will return void, and we can call the method anything we like, but rather as we did in the XML, this method name needs to describe the intention of the point cut. So the point cut is going to be, let's make it just all service methods. I won't bother with service methods that return lists this time around. And it's just a parameterless method. There's just round brackets there. And you leave the method body empty. So we just have open and close curly brackets. Now, it's a really weird method in that we're never going to call this method. It's really just a tag or a marker method. But the idea is that we add an annotation to that method. So it's almost like this is just giving us a hook to hang our point cut annotation to. So the annotation is, of course, point cut, and then you specify in round brackets just the string representing your point cut. So it's going to be, again, our old friend execution, and we don't care what the return types are, but we want to apply the advice to all classes in the com.virtualpairprogrammers.avalon.services package, and we want to apply the point cut to all classes and then all methods inside there, and we don't care what the parameters going into the methods are. So I have a compile error, and that's because I don't think I've imported point cut. So Control-Shift-O, and just to check, there's the import. So that's compiling now, and all we do in the around tag now is string with name of the method that defined that point cut. Now, of course, if you wanted a different point cut for our around advice and our before advice, you just go ahead and create further point cuts. Now, I must admit, I think that's a very strange system that they've set up. Very unusual to have a method in Java with an empty method body. But if it works, I guess you have to admit that these three annotations replacing the big block of XML that we had before is arguably a little neater. Let's check that this runs. Now, it's telling me that the point cut is not well formed. And it is a little bit confusing, this. I guess you might be inclined to go into the point cut and check that everything's okay there, but it's just a little bit of a tricky thing that I always forget to do. When you put the name of this point cut method in here, you do have to include open and close round brackets. I always forget to do that. Let's see if that runs now. Well, yes, that's looking good. You can see that the before advice is running and the around advice. And remember, this time the advice is a little bit more general. I've applied it to all of the service methods. I don't know which of the two approaches you prefer. You can go with either the AOP namespace that we saw in the XML, or you can use the annotations. And I guess if you're working on a project, they will have made a decision on which they prefer. I'll tell you the reason that I don't like the annotation version. It's just that now we have the details of our AOP, how we want it to be applied, hard-coded into the code. If I wanted to change this point cut, Perhaps we have finished using performance timing and we want to switch it off. Well, using the annotations, I would have to go into this class, change the Pointcut here, and recompile the code. Whereas with the XML version, well, it's not there anymore, but if I had the AOP namespace version, then all I'm doing here is editing a configuration file, and I wouldn't have to recompile. And I just like that level of kind of being able to switch the advice on or off, or change the classes to which it applies in a configuration file feels to me a lot more natural. However, having said that, a lot of people do prefer this new annotation version. So what I'm going to do for the practical code that's in your practicals and code folder, I'm going to provide 2 copies of the workspace, one with the annotations and one with the XML. Now, of course, we need to do a practical session on AOP, so I'm going to be switching across to our CRM system in the next chapter, where you'll be flying solo with AOP, and I'll be allowing you to use any of the approaches that we've seen so far. So, the Pointcut syntax borrowed from AspectJ is a powerful way of defining where you want your advice to apply. All service classes, all DAOs, just methods beginning with the letter Y, it goes on and on. The advice class is now plain Java, which means we can have more than one piece of advice in a class. The AOP namespace gives us a lovely set of tags, giving you real power and control over the advice, without massive blocks of XML beans. You can go for annotations instead. I've made my feelings clear on this. I don't like having my point cuts defined in code. I do like annotations for other tasks, as we'll see later, but not here. Your opinions may vary though. As promised, the next chapter is another practical, your chance to practice AOP for yourself.